So I will be collecting those papers. You can have one person go ahead and collect them from the table, bring them up to me, and then we're going to go ahead and work on our notes for today. Our objective is the exponent. I'm sorry, this is getting recorded, and there is no need for that noise level. You have a piece of paper, you grab it from the people at your table, and you bring it up. Then you get ready for taking your notes. Homework? Did we get it from you guys already?
Where we put it?
Ladies and gentlemen, I'm horrified at your behavior. I'm writing, and we're taking notes, and you guys think it's time to have a chat session. Focus in on what you need to do. We're going to talk today and learn about the exponent rules for dividing monomials with like bases. So what we're going to do is the same exact kind of strategy that we did yesterday, where we're going to put some problems up. We're going to figure out what they mean. We're going to see what we have. And then after looking at a couple of examples, we're going to try to come up with a rule. Once we establish the rule, then we can apply that in our homework and we don't have to go back to drawing pictures. If you are confused, then you can go back and draw pictures. Justin. We gave it yesterday. A monomial is a term that doesn't have adding or subtracting going on. It's just a term. It could have a coefficient. It could have one variable with exponents or without. It could be multiple variables being multiplied together, but it's a single standalone term. 1 is a monomial. X is a monomial. 5x, 5x squared, x squared, y squared, z squared. All of those are monomials because there's no adding or subtracting between the pieces. Okay? All right, so let's start with x to the 6th divided by x to the 4th. Okay? So, Sean, what does x to the 6th mean? Okay, so tell me what to write. One, two, three, four, five. Oops, we need one more. Okay, so that's what x to the 6th means. It means x times x times x times x times x times x. Okay, and then Matthew, what would x to the 4th mean?
X times x times x times x.
So we don't have quite as many x's on this one, right? So we're going to apply something that you guys learned a long time ago in elementary school, is what do you have when you have a number divided by itself? So what do you get when you have 2 divided by 2?
1.
Or 50 divided by 50?
1.
Or a million divided by a million?
1.
Okay, so anytime I have something that's the same in numerator and denominator, it actually equals 1, because fractions are just a fancy way of writing a division problem. So if you look at what we have here, what does x divided by x equal?
X.
Not x. 1. How about x divided by x? How about x divided by x? How about x divided by x? So what's left over?
2.
We have an x, and there's 2 of them, and we would write that and read that as x squared. Okay? All right. Looks interesting. Let's try another example. How about 8 to the 5th power divided by 8 cubed? Okay, hold on. Don't jump to the conclusion yet. Hold on to that thought. I'll get back to you on that one. So first, we need to write, what does x to the 5th mean? Ryan. I mean 8 to the 5th, sorry.
8 times 8 times 8 times 8 times 8.
Okay, good. And then, Cameron, what would x, or 8 cubed mean?
8 times 8 times 8.
8 times 8 times 8. All right, good. Paloma, do we have any of those pairings that we can deal with that we did like in the last problem?
3.
Yeah. We've got 8 divided by 8,
1.
and another 8 divided by 8,
1.
and another 8 divided by 8. And so what are we left with? We're left with an 8, and there's 2 of them, so we get 8 squared. Okay, now, what I want you to do is look at the original problem on the left, x to the 6th divided by x to the 4th, and the answer we got, x squared. And I want you to look at the problem on the right, 8 to the 5th divided by 8 cubed, and we got 8 squared. Can we come up with a rule that we can use anytime we have a division problem with monomials that have like bases? Jonathan, what did you see?
I have a question.
Okay.
Why are the ones that
Because what's 8 divided by 8?
1?
That's why the 1 is there. It's showing you that those two pair up and give you a 1. Okay. Rochelle?
I also have a question. So you want us to simplify, like 8 to the 2nd?
It depends on the directions.
Okay.
If the directions just say write using exponents, you would leave it as 8 squared. If it said simplify, then you need to go to the next level. Okay? All right, Mackenzie.
It's like subtracting.
Okay, give me, it's like subtracting. You got to give me some more. What's doing the subtracting? What's happening? So when you, look at your title of our notes. When you,
Divide monomials with like bases. You group them. The other.
just look from the start to the bottom. Can you come up with a rule so that we don't have to draw the pictures anymore? You start off really well. When dividing monomials with like bases, what ended up happening with the exponents?
You subtracted them.
Very good. So that's our rule. When dividing monomials with like bases meaning same variable, same exponent, with like bases, subtract, and I want you to box up that word, the exponents. And notice that when I did the 8 to the 5th divided by 8 cubed, I still had an 8 in my answer. I have a lot of kids will tell me, well, 8 divided by 8 is 1, 5 take away 3 is 2, and they get 1 to the 2nd power. Okay, the base cannot change, because then you completely change the meaning. So subtract the exponents, and the base remains the same. Okay, Mackenzie.
Question.
Yep.
If the numerator was smaller than the denominator.
We're going to get to that. Hold on. Good thought. Good question. That's what happens as you're doing this. You all of a sudden have what ifs. Well, what if I have this? What if I have that? Okay, we're going to get to that. Jonathan.
What's that word after base?
Which word?
Word after base.
Remains. Remains the same. Okay, Anthony, you have a job to do, and it's not to play. Okay. Everybody got the rule down? Elijah, you good? Okay. Everybody good? Hold up your book. Let me see. Okay. Make sure that when you're doing notes that you guys are writing down the date as well. Okay, so let's deal with that notion of what if it's not just a monomial base, that there's also that guy in front. And let's see if you guys can remember what he's called. Let's see, what do I want to write? How about, oh, sorry, let me change colors. What if we have 6x to the 5th divided by 2x? Okay. By the way, what do we call the 6 and the 2? They have a special name. They're not bases. They're called coefficients. So these guys here, they're called coefficients. They're the numbers being multiplied by a variable in a monomial. Okay? All right, so I'm going to erase this. Put it back in the black. Okay. All right, so let's do what we did on the last one. Let's talk about meaning. What does 6x to the 5th mean, Liam?
6x. So you go. Wait, hold on, I need to- Wait, say it again?
How would I write what 6x to the 5th power means? So kind of look at what we did before. What does something mean?
Oh, you would. You 6? No.
Mm-hmm.
Yeah, 6. And I think times x. Times x. Times x. Times x. Times x.
Excellent. That's exactly what it means. I have a 6 times x 5 times. Okay? Good. Perfect. All right, and then let's see. What does Chase 2x mean? 2 times x, right? Okay. Do we have any matches where we have same term in the numerator and denominator and they give us a 1? Elijah is holding up one finger. What do you mean by one finger? Yeah, if you look here, you have only one matching numerator-denominator value. Okay? So what's strange when we did this problem, Kia, you got to be writing this down. Focus. Is that we have a 6 divided by a 2. We didn't have any repeaters, so we write it like that. And then on the x's, though, what did we have? How many left?
4.
We had 4. Now, can we do 6 divided by 2? Yes, and that's what we're going to need to do. What's 6 divided by 2? 3. Okay. All right, let's try another version. What if the original problem was like 12y to the 7th divided by 15y to the 4th? Okay. So Sean, can you tell me what 12y to the 7th means?
12 times y, minus 1.
Because. Oh, now you don't laugh. What a bunch of bozos. Courtesy laugh, thank you. Okay, and let's see. Chloe, what does 15y to the 4th mean?
It would be 15 times y times y times y times y.
Okay. And Sarah, do we have any matches, numerator to denominator, that will give us a 1?
Yeah. 4.
So we have 4 pairs of y over y that equals 1. So what we're left with is a 12 divided by 15. And how many y's did we end up with? 3. Okay. Now, can I divide 12 by 15? Because that's really all a fraction is a division problem. So what's our next option that we could try? We can try to simplify. And what do 12 and 15 have in common?
3.
Okay. So we divide by 3, and we get 4/5 y cubed. Okay, now let's make sure we understand how to write an answer that has a fractional coefficient. You can either write it this way, where the variable is opposite the fraction bar, or you can put the variable in the numerator and the denominator stays by himself. Those are the only two choices. If you put the y cubed in the denominator, your answer is completely wrong. Okay? All right, now let's look at the exponent part. Did it follow the rule that we came up with on the other page? So on the 6x to the 5th divided by 2x, was I able to apply the rule when dividing monomials and the bases are the same, subtract the exponents? X to the 5th divided by x. If I took my exponents, Did that match? Yes. Do I get to subtract exponents on the coefficients? Okay. Anthony, you're done. Go sit in the very back of the room, because your job is to learn. Adam, if you're going to get in the way of somebody else learning, then you're going to get suspended out of my class. Okay? Did the rule work for the variable part? It did. Okay, verify. How about on the 12y to the 7th, 15y to the 4th? Did the rule on the exponents work in the division problem?
Yeah.
It did. So that works. But we need to add something that deals with what happens with the coefficients. But before we do that, I want to do one more example. What if we have 4z cubed over 8z squared? Okay. Let's see if we can do this applying the rule. So we're not going to draw out the meaning, because I think we kind of agree with the rule. Chase, this isn't snack time. You guys are not supposed to be eating in class. He's chewing. Okay, you should not be drinking. Thank you. Okay. What am I going to do with the 4 and the 8? What am I going to do with that? Cleo. Okay, well, first off, how do I write this? Somebody have a cell phone on? Okay. What do we write? Think back to these examples. Look in purple. What did we do with our coefficients? Okay. So what would I be putting here? 4 over 8. Okay. And then, let's see, Faith. With my exponents on my like bases, what am I going to do with those? No. Remember, we're going to try to apply the rule. What would we do in a division problem when the bases are the same? What happened to the exponents? We're going to subtract them. So what? Tell me exactly the order to write it. So what I'm doing is I'm doing numerator, take away denominator. Okay. Now, at this point, I can't deal with this one, but I can simplify over here, and I get 3 take away 2 is 1. Now, what you're not going to be doing, Sean, is adding 1 as the denominator. Now, Kaleo, you're eating? Gentlemen, what is going on today? Okay, if you guys are going to be chewing and having your mouth go up and down like this, I'm going to think you're eating food in class. Okay? You guys can't do that. You can make it to 4th period. I don't get to eat. You don't get to eat. Now, can I do 4 divided by 8? No. What can I do? Okay, what do they have in common? They have 4. Always look for the greatest common factor. So I get 4 divided by 4 is 1, 8 divided by 4 is 2, and a z. Now, the reason why I wanted to put that one up in particular is because I have a lot of students who will tell me 4 divided by 8 is 2, and they'll write their answer as 2z. But that can't possibly be because 4/8 was less than 1, so my coefficient still has to be less than 1. So we need to keep that going. So that's one way to write the answer, or 1 times z is z over 2. So those are the 2 ways to write that answer. All right, so let's see if we can come up with a rule that we can use when coefficients are involved. So I'll start. When dividing monomials with coefficients and like bases, what are we going to do? Okay, Justin? Now, were we able to divide every time? Okay. Okay, so what we're going to do is add both of those. So we're going to divide or, and I might use the word reduce the coefficients, depends on the situation. And then what would we do, Mina, to the exponents? So I had 3 for the exponent on top, 2 on the bottom. I ended up with 1 in my answer. What math did I do to get to 1z in the denominator? Look at the second step. What math did we do with the exponents? No. Look at step 2. What math did we do with the exponents? We subtracted. So that part hasn't changed. So we divide or reduce the coefficients and subtract the exponents on the like basis. And just to add this last little bit, make sure that we understand that subtraction is numerator minus denominator. Okay? Very important that we follow that order. Okay? So what are some what-ifs you might have about exponents at this point? What's a what-if you might have? Cleo?
What if the exponent on the numerator is the exponent on the numerator is smaller than the one on the denominator?
That's a great what if, and you know what? We're going to talk about that on Tuesday. Okay, so what happens if the exponent on the variable is larger in the denominator than the numerator? We'll talk about that later. Okay?
Sorry, but the homework's in the green book, right?
Okay. We need to focus in on what I've asked. Okay? What was the third example, the last group of examples that we had on yesterday's notes? What kind of how was that last problem that we dealt with on yesterday's notes different from the other problems? Chloe, what does it look like?
Want me to read it to you?
No, you just tell me how that problem was different from the other problems or different from the ones we've done so far. What do you notice about that last example?
There was letters. I don't know.
Okay, was there just one variable?
There was 2.
Okay, so we had more than one variable. So that would have been a what if too. What if there's more than one base? So let's deal with that example, and that'll be our last one. So let's say we have 8, well, let me change this to black again. What if we had a squared b to the 5th c to the 6th, and I want to divide by a b squared c to the 4th? How would the rules apply to this problem? Okay, Cameron?
Maybe like divide like
No. Tell me what you're going to say.
like divide A, B, and C.
All right, go back to the first rule that we had in our notes from today. The first rule. And what did it say to do when dividing monomials and the bases were the same? What are we going to do with the exponents? What's the exponent rule? We're going to subtract the exponents. So should we do A, B, C together, or should we do them separately? Okay, so let's focus in on the A's. What would I do to get to the final answer for how many A's I have in this problem? Tell me the actual math problem I would do.
Like write it out.
Just tell me what to write here. I've got A, and what math am I going to do? So in the numerator, what was the exponent on the A?
Is A times A.
Okay, no, we're not going to write out what it means. We're going to try to apply the rule. So some of you were saying, well, what am I supposed to show on my homework? This problem is what I would see on your homework. Okay, so what's the exponent on A in the numerator?
Squared.
Okay, so that's a 2. And then what math am I doing between that exponent and the one for A on the bottom? What math? What the rules say?
Subtract.
We're going to subtract. And what's the exponent on the A on the bottom?
1.
Okay, so we've got A to the 2 take away 1 power. All right, and then B, Adam, what am I going to write for the exponents? What's the math problem I'm going to do to figure out how many B's I have?
2 minus 5.
Okay, remember what we just wrote at the bottom in blue? What's it say to do? Yeah, you shouldn't be packed up because we're still doing our notes. Okay, look at what I have here in blue. What's that between the numerator and the denominator? It's a minus. So what's the exponent in the numerator on the B? And what's the exponent on the denominator of the B? So I have to go in that order. Numerator, take away denominator. Top, take away bottom. Okay, and then on the C, let's see. Kia, what am I going to do? Kia, look at what we did for A. Look at what we did for B. Look at where those numbers are coming from. I want you to do the same thing with the C. 6 minus 4, good. Courtney, tell me what the final answer is.
A, B to the 3rd power,
Or B cubed
and C squared.
and C squared. And that's basically what you need to do. Now, most people can do the subtraction in their head, and they would have original problem equals answer. Okay? If you need to write it out so you don't make a careless mistake, then you write it out. All right, so it's page 207, 23 to 38, 61 to 66 in the green algebra book. We have not started using the other book yet.